Look up at the night sky. What do you see? You see stars, countless and shimmering, sweeping out, the Milky Way, billions of stars. We used to think Earth was unique, a special lonely marble in the cosmic dark. But the universe is more imaginative than we ever dreamed. What if I told you there are worlds completely covered in water? Not just lakes or seas, entire planets that are one planet-wide ocean. These are not fantasies. The laws of physics and chemistry suggest they must exist. Imagine a place with no ground to stand on, no continents, no islands, not even a single pebble of dry land, just water, everywhere, from pole to pole, an unbroken expanse of liquid under a distant sun. This is an ocean planet. Our galaxy, the Milky Way, has billions of stars. Many of those stars have planets. Statistically, some must be water worlds, we just have to look. This chapter is about worlds of endless blue, holding secrets we're beginning to guess at. Think about water, the stuff of life on Earth. So, how do we find a planet that is trillions of miles away? We can't just point a telescope and see it. These worlds are too small, too dim, too far. We become cosmic detectives looking for clues. One of the best methods is called the transit method. We watch a star very carefully. If a planet passes in front of its star from our point of view, it will block a tiny amount of the star's light. The star will dim, just a little bit. That dip in brightness is our clue. It's like a moth flying in front of a distant street light, telling us something is there, even if we can't see the moth itself. That little dip in starlight tells us a lot. It tells us a planet exists. By measuring how much the light dims, we can figure out how big the planet is. By measuring how often the dimming happens, we can figure out how long the planet's year is, and how close it orbits its star. This helps us guess its temperature. Is it in the habitable zone where water can be liquid? But to know if it's an ocean world, we need more information. We need to know its mass. We can measure a planet's mass by watching how it tugs on its star, making the star wobble ever so slightly. Once we have the planet's size and its mass, we can do some simple math. We can calculate its density. Let's travel with our imaginations to the surface of one of these ocean planets. What would you see? There is no shore, no beach, no cliffs, just water, in every direction, as far as the eye can see. The horizon is a perfect, unbroken circle of blue-green, or maybe even a color we have no name for. The sky above might be filled with clouds made of water vapor, thicker and heavier than any on Earth. The sun, a distant star, might look bigger or smaller, or be a different color, perhaps a fiery orange or a cool, pale white. The waves here could be enormous, titanic swells traveling for thousands of miles without interruption. The weather on such a planet would be unlike anything we know. Without continents to block their path, storms could grow to unimaginable sizes. Hurricanes the size of entire continents on Earth could churn across the global ocean for years, even decades. The wind would never cease, constantly whipping the surface into a frenzy of spray and foam. Rain would not be a brief shower. It could be a constant, planet-wide downpour that lasts for centuries. The sounds would be immense, a constant roar of wind and water, a symphony of a world in perpetual motion. And what about the water itself? It might not be the same as Earth's oceans. Depending on the minerals dissolved within it from the planet's core, the water could be thick and syrupy, or maybe fizzy with dissolved gases. It could be incredibly salty or almost perfectly fresh. The color might not be blue. If alien algae or microbes fill the upper layers, the ocean could be a vibrant green, a deep red, or even a shimmering, oily purple. In the upper layers of this global ocean, where sunlight can reach, there would likely be countless trillions of tiny organisms. They would be the foundation of all life, just like the plankton in Earth's seas. But maybe they would be more exotic. Not just green with chlorophyll, but have evolved to use different parts of their star's light. They could be glowing red, or a brilliant gold, turning vast regions of the ocean into a colorful living soup. As you descend deeper, the sunlight fades and the world is plunged into eternal darkness. On Earth, we call this the midnight zone. But here, on an ocean planet, this zone could be hundreds, even thousands of miles deep. In this realm of total blackness, life would need to make its own light. This is called bioluminescence. We see it on Earth in fireflies and deep-sea fish. But on a planet that is mostly deep sea, it would be the primary form of communication and survival. The darkness would be filled with a constant silent fireworks display of living light. Imagine swarms of tiny shrimp-like creatures flashing in perfect unison, creating waves of blue and green light that ripple through the abyss. Predators might use a single bright lure to attract their prey, a deadly pinpoint of light in the crushing dark. Other creatures might be covered in complex patterns of light which they use to signal to mates, to warn rivals, or to camouflage themselves against the backdrop of other glowing organisms. The dark would not be empty, it would be a canvas, and life would be the artist, painting with light. In an ocean that is practically bottomless, there would be no limit to how large something could grow. On Earth, the size of a whale is limited by many things like needing to navigate shallower waters. But on a planet with a truly global deep ocean, constraints are fewer. The immense pressure of the deep could support enormous bodies. Here, in eternal night, could lurk creatures that dwarf anything on Earth. Leviathans, beings the size of mountains, their forms shaped by eons of evolution in a world of water and pressure. What would these titans look like? They might not look like fish, they might not look like whales. In the absence of light, eyes might be small or non-existent. Instead, they might use hyper-evolved sonar clicks calls that echo across vast distances, painting a picture with sound, or be covered in sensors for tiny pressure changes or faint electrical fields. Comparing an ocean planet to our Earth is like comparing a single garden to an entire rainforest. Both are beautiful, but their complexity and scale are vastly different. Earth has an incredible diversity of environments: dry deserts, frozen tundras, lush forests, soaring mountains. An ocean planet, on the other hand, would have a different kind of diversity. It would be less about different environments and more about different depths. The surface might be a raging, sunlit world of high energy. A few hundred feet down, it would become a calmer, dimmer twilight realm. A mile down, it would be a world of absolute blackness and immense pressure. One of the most beautiful things about Earth is the boundary between land and sea, the coastline. This difference also means the history of a civilization would be impossible on a water world. Let's put on our science hats for a moment, but don't worry, we'll make it fun. The science of an ocean planet is fascinating. First, the pressure. Water is heavy. Here on Earth, if you dive just 33 feet down, the pressure doubles. Now imagine an ocean that is 100 miles deep. The pressure at the bottom would be immense, thousands of times greater than on Earth's surface. It would be strong enough to crush steel, to crush rock, and to change the very nature of water itself. The laws of physics are the same, but the conditions are extreme. At the very bottom of this massive ocean, something amazing could be happening. Under that much pressure, water stops being a liquid as we know it. It can become a strange form of solid called ice. Not cold ice like in your freezer, but hot, dense ice. Scientists call it Ice 7 or Ice 10. So, at the very seabed of this ocean planet, there might not be rock. There might be a layer of exotic, high-pressure ice. This changes everything. On Earth, volcanoes on the ocean floor release minerals and heat into the water, feeding life. On an ocean world, this layer of ice could separate the rocky core from the liquid ocean above. Now it is your turn. Close your eyes. I want you to imagine you are an astronaut, a cosmic explorer on a mission to this ocean world. Your ship has traveled for years across the void, and you have finally arrived. You are floating in orbit, looking down at the planet through a viewport. You see no land, no familiar green and brown continents, just a swirling, endless sphere of deep blue and white clouds. It is mesmerizing, beautiful, and a little intimidating. This is a world untouched, unseen by human eyes until this very moment. What thoughts are going through your mind? Your mission commander gives the go-ahead. You climb into a small submersible, a vehicle designed to withstand both the vacuum of space and the pressure of the deep. The craft detaches from the mothership and begins its descent. You pierce through the thick cloud layers, turbulence shaking your vessel. Then, you break through, and you are flying over the ocean's surface. The waves are colossal, mountains of water rising and falling in a slow, powerful rhythm. The sheer scale of it all is hard to process. You are a tiny speck above an infinite ocean. The universe is under no obligation to make sense to us. It is what it is, and what it is wonderful. These ocean worlds, these cosmic mysteries are not just daydreams, they represent the frontier of human knowledge. Every time we point our telescopes to the sky, we are writing the next chapter in the story of discovery. A story that began when our ancestors first looked up at the stars and wondered, what are they? Now we are looking at those stars and wondering, what kinds of worlds orbit them? And is anyone home? The quest for knowledge is the most noble of human adventures. Exploring these worlds, even if only with our telescopes and our probes, will teach us more about our own planet. It gives us perspective. If you found this journey into the cosmic ocean as thrilling as I did, subscribe to this channel, give this video a thumbs up and share it with someone who still looks up at the stars and dreams. Thank you for joining me.